Hey, this is Mr. Ward, and I'm going to do a quick video on how to graph lines. Hopefully it's quick. It might take a little while. Maybe I'll break it up into a few. So first of all, I'll talk about how to graph linear equations that are in the slope-intercept form. And here I have a couple of those. And then I'll mix that up probably with inequalities as well. So here we have y equals negative 2/5 x plus 4. And so what we can do with this is whenever we're graphing lines, we want to see what points we can identify. Now, there's one point that this equation gives us, and that's the y-intercept. There's going to be a point at 0, 4. So you can write down right away that 0, 4 is a point that you would have on this line. So let's go ahead and move one of these dots to 0, 4. So I'm going to move it right there. Now it's at 0, 4, and we've plotted one point. But we don't know yet where another point is. To figure out where another point is, we want to turn to the slope. Now the slope is saying negative 2/5. What that means is down 2 to the right 5. So this is in the rise over run structure already. So vertical change over horizontal change. So you could either say a vertical change of negative 2 over a positive horizontal change of 5, or you could put that negative in the bottom and you could say a vertical change of positive 2 and a negative horizontal change of 5. So let's see what that means. So what we're going to do is we're going to go from this point. Let's bring the other point over here, and we're going to take that point and we're going to go 2 places down, and then 1, 2, 3, 4, 5 places over. So that's one way you could approach it. Just move that according to what the slope says. And obviously this Google Draw Space doesn't do it perfectly, but mathematically you could do it this way. You could say, all right, my y is going to be, from here, I'm going to take the y value and I will subtract 2. And over here, I'll take the x value, okay, and if I'm going down 2, the x value is up 5. So I now have a new point, which is expressed as a couple of expressions, but I can simplify those. 0 plus 5 is just 5, and 4 minus 2 is just 2. And let's see, did I end up at 5, 2? Yes, I did end up at 5, 2. Okay, so now I have 2 points, and I can just take my line and move it so it goes through those 2 points. So let me grab the end of the line. Okay, I'm going to have to rotate it around a little bit, but that's okay. Okay, so I've got it going there. I'm going to adjust it here and adjust it a little bit so it goes through there too. So it might take me a couple maneuvers. Of course, if I were doing this on paper, it's a lot faster. Sometimes if you just get it sort of lined up like that, now it's sort of parallel to the 2 points, it's a little easier to just move it, the whole line onto them. So now we have that line. I want to also let you know that we could grab one more point if we wanted to. So remember we had that 0, 4. Now, instead of subtracting 2 and adding 5, I could also add 2 and subtract 5. And the reason I can do that is negative 2/5 is the same as negative 2/5, which is the same as 2 over negative 5. Those are all the same thing. So now I have a point here at negative 5, 6. And negative 5, 6, if I wanted to, I could grab this point and move it over to, oops, I'm not trying to stretch it out. Let me undo what I just did. Okay, so Control Z. If you get stuck, you can always Control Z that thing. Okay, it seems to think I want to stretch it. Now, here we go. So negative 5, so there's negative 5, and there's 6. And if I wanted to do this, I could stretch my line out a little bit. So now it goes through those points, and I'm still lined up the same way I was. So I could get those points as well. Cool. So that's how you graph that one. All right. Now let's take a look at graphing the other one. Well, actually, first, let's look at what it would mean if this were an inequality. So if it were less than or equal to, then I would need to figure out, what I need to do is figure out, what I need to figure out is which side, I'm going to hold off on that. I'll make a separate video on the inequalities. I think that's probably a better idea. But I'm going to need to figure out which side of this line is shaded and whether this line is a solid boundary that is included in the inequality, or it's a dashed boundary for the inequality that is not included. And that's the difference between a and less than or equal to, and a less than, or a greater than or equal to, and a greater than. One is equal and one is not. So let's talk about this next one, y equals 4x minus 5. So once again, we're given a y-intercept at -5, so we can immediately plot a point at 0, -5. Okay, so let's go ahead and grab one of our points and put it down there. Ooh, it's deciding to stretch again. I know this is not the perfect solution to being able to graph our lines, but here we go. 0, -5. I've moved that point. Now I need to find another point that is on the line. Now, my slope is 4, and sometimes people get a little confuzzled about what do I do with, I can deal with the fraction version, but the whole number, I don't know what to do. Well, that's 4 over 1, so now it's a fraction. So that's a vertical change of 4 and a horizontal change of 1. So we can do it mathematically and work that out. So the horizontal change will be added to the x, so 0 plus 1, and the vertical change will be added to the y, -5 plus 4. And I can simplify that. That becomes just 1, and that becomes -1, -5 plus 4. So I've got a new point at 1, -1. So let's grab this one, and it's going to be at 1, -1. So there we go. We've plotted 2 points for the line, and once I have 2 points, I can just move this line into position. Okay, I'm a little off, so I'm going to move it there and nudge it over. Okay. And on this utility of Google Draw, if you're slightly off, it's okay. So there I've got another point. Now we could get one more point. Let me actually show you how you can get a point that, so I've shown you how you could get a point that's the opposite direction. I'll do that one more time. We can treat 4 over 1 as -4 over -1, and we can say 0 minus 1, comma, so that's the horizontal change, and -5 minus 4, and that'll get us another point at -1. -5 minus 4 is -9, so I would have another point down here at -1, -9, and you can see the line actually already goes through that point. But slope can be scaled up and down too. This is all the art of mapping with slope. 4 over 1 is the same as 8 over 2. So instead of adding 4 to the vertical and 1 to the horizontal, I could add 8 to the y and 2. Add or subtract. Add 8 to the y and 2 to the x. So let's see what happens when we do that. So 0, this is the x part, so I'll add 2, because 8 over 2 is the same as 4 over 1. And I'll add 8 to -5. And now I've got a new point that's going to be at 2. And -5 plus 8 is going to be 3. So let's find that. That's going to be 2, 3. And in fact, the line goes through 2, 3 as well. So you can use this slope mapping tool to get additional points. If you want points that are further apart, you can do that. Now, you might notice that the fraction form of the slope is much easier to work with. I can more easily scale it up and down, much easier than if I had used negative 2/5 had become negative 0.4. That's going to be harder for graphing. So I encourage you to let go of any attachments you have to decimals always being best. Decimals are good when they are good, but sometimes they are bad and you don't want them. So please use fractions for mapping slope. And when I say mapping, that means I'm taking a point that I know and using the numerator of the fraction to define what my vertical change is going to be from that point to map to a new place. And the horizontal, the denominator will give me my horizontal component of my change. And then the sign of the slope will help me know whether I'm going up to the right or down to the right. A negative slope is down to the right. A positive slope is up to the right. And I'm going to stop on that one, and then I'll do another one on point slope form.